Alright, so this problem is actually fun. So we are asked to find the perimeter of the triangle PQR. So this is our triangle PQR, and it is plotted in our Cartesian plane with the coordinates negative 2, 3. That's Q. And then R, we have 3, negative 2. And then P is 0, negative 5. So again, there are different ways to solve this problem. First thing is we are going to make use of the Pythagorean Theorem. And then the second one, we are going to make use of the distance formula. Alright, so we're going to make use of the distance formula. And then you're going to check which of these two methods will work for you. Alright, so let's start with the Pythagorean Theorem first. So again, to get the perimeter, we need to get the distance of this one, and this one, and then we're going to add them together. So let me just write that. The perimeter of this triangle is just equal to what? We have QP plus, let's say, PR, and then RQ. Alright, so again, we need to find the distance from QP, and then from PR, and then from RQ to get the perimeter. Now again, as I told you earlier, we're going to make use of the Pythagorean Theorem to solve this one first. So what is QP? Now, to do the Pythagorean Theorem, what we can actually do is to drop right triangles here, and then we are going to solve for the hypotenuse. So again, if we are going to drop a segment here and here, we actually form a right triangle, right? So again, from here to here, that is what distance? We count 1, 2, 3, 4, 5, 6, 7, 8. So meaning to say this is actually 8. And then from here to here, that is just 1, 1, 2. This is 2. So to get this side, to get QP, so QP is just equal to the square root of 8 squared plus 2 squared, which is just equal to 64 plus 4 squared. This is just square root of 68. So that's my QP. Alright, or if I'm going to get my calculator, what is that? To the nearest, let's do square root of 68. That is just 8.25. So I'm gonna write this is 8.25. Alright, that's my QP. That's my QP. Next, I'm going to look for PR. So again, I'm going to draw a right triangle here. This one. And then again, this is a right triangle. So from here to here, that is just 1, 2, 3. This is 3 units. And then from here to here, that is just 1, 2, 3. That's another 3 units. Alright, so again, I'm going to write my PR. PR is equal to the square root of, I'm gonna do 3 squared plus 3 squared. This is just 9 times 9, that's 18. So I'm gonna have square root of 18. So my PR actually measures how much? PR measures, let's grab the calculator. So that is just square root of 18, and that gives us 4.24. So this is just 4.24. And then for the last one, I'm going to draw a right triangle here, this one, and I'm going to count 1, 2, 3, 4, 5. This is 5 units. And then this is 1, 2, 3, 4, 5. This is another 5 units. So meaning to say, my QR actually, or RQ, my RQ is just equal to 5 squared plus 5 squared, and this is just equal to 25 plus 25, that's square root of 50. So square root of 50, that is actually equal to how much? Square root of 50, that is 7.07. So that is 0.07. So that's my RQ. Now again, to get my perimeter, I'm just going to add them together, right? So this is 8.25 plus 4.24 and then plus 7.07. So if I'm going to add them together, I actually will have 8.25 plus 4.24 plus 7.07, and I will get 19.56. So my perimeter is just 19.56 units. Alright, so a perimeter of this particular triangle. Now, how do we find the same perimeter using the distance formula? So, as a review, when we talk about distance formula, distance is just given by, we have x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 and then squared. Alright, so we have here points Q. Say Q, again that is negative 2 comma 3, and then we have P, which is 0 comma negative 5, and then we have R, we have 3 comma negative 2. Alright, so again the same thing, we are going to solve for QP, PR, and then RQ. So let's try to do that using the distance formula. So the distance from QP is given by, I'm going to take 0 plus 2 and then squared. Why 0 plus 2? I have this. Not plus 2, by the way. That's minus 2. Oops, where's my eraser? Wait, that should be minus 2. Minus 2 squared. Now, maybe you're asking why do I have 0 minus 2? Again, this is my x sub 2 minus x sub 1. Alright? And then plus, this is my y sub 2, that is negative 5 minus 3 squared. And then again, this will become 0 minus 2, that's negative 2 squared, that is 4, plus negative 5 minus 3, that's negative 8 squared, that is 64. Alright, and then if you notice, that is just the same here, right? That is just the same here. So I know that this will actually give me how much? 8.25. This is 8.25. So my, again, QP is 8.25. Now, what about my QR? So QR, I'm gonna do QR is equal to, this is QR, Q, and then R. So I have 3 minus negative 2. So that is just 3 minus negative 2, that is just plus 2 squared plus negative 2 and then minus 3, that is squared. And then again, this gives me negative 3 plus 2, that's 5, and then squared, that is 25, plus negative 2 minus 3, that's negative 5 squared, that is 25. And again, I know this is square root of 50, and this is this, right? So I know that square root of 50 is just equal to 7.07. And then the last one, I'm gonna do PR. So my PR will be this one, PR. I don't know if you're seeing this, PR, this PR. So I'm gonna have segment PR is equal to, that's square root of 3 minus 0 squared plus negative 2 plus 5 squared. Why plus 5? Because again, look at this. This is 3 minus 0, and the negative 2 minus negative 5, that is negative 2 plus 5. So this will become square root of 3 minus 0 is 3 squared, that is 9, plus negative 2 plus 5, that's 3 squared, that is actually 9. And this is square root of 18. And I know that square root of 18 is just 4.24. So again, as you can see, I have here the same values. So I have 8.25. This is 8.25. 7.07. This is 0.07. And I have 4.24. This is 4.24. And again, if I'm going to add them together, it will give me the perimeter, which is just equal to this one. So again, this is how you solve for the perimeter using either the Pythagorean theorem or the distance formula.